We'll now begin section 9.2, where we will look at our second type of conic, which is called a parabola. A parabola is a shape that we are familiar with from previous courses. We know that the shape of a parabola is that of a U, and that the point along the bottom of the parabola, in this case, is known as the vertex. What you may not know from a previous course is that there are two other things that we need to identify when we start talking about a parabola. One of those is what is called the focus, and the focus point is always going to lie on the inside of the parabola. So the parabola is going to wrap around that focus point. We also have a line that's going to come on the back side of the parabola that's going to be known as the directrix. Let's take a look at our formulas. We have two versions of a formula that will apply for parabolas depending on how the parabolas are opening. The standard form of the equation of a parabola with vertex at hk can either be denoted by this formula or by this formula. Now, if you note the difference in the formulas, basically you have the difference being that in the first formula, the x minus h is squared, and in the second formula, the y minus k is squared. So if the x is squared, you know that the parabola is going to be vertically oriented, which means that the parabola is either going to open up or it's going to open down. If the y value is squared, it's going to be horizontally oriented, which means that the parabola is either going to open to the left or to the right. The p-value is going to help us to determine the focus and also the directrix, and we'll look at that when we look at an example. Okay, so our first example asks us to graph the parabola y plus 2 squared is equal to 8 times x minus 4 and determine its focus and directrix. So let's begin with identifying the vertex for the parabola. Remember that the vertex is going to be defined by the h and the k, and the h and the k are the numbers that are subtracted off from the x and from the y. So if I look in my x parenthesis, and I see here I have a minus 4, and we saw this rule happening when we talked about the ellipses in the last section, we want to use the value that is the opposite of what we see. So if we see a minus 4 for the x, we're going to use a positive 4 for the x value in the vertex. And if we look in the y parenthesis and we see a plus 2, we're going to do the opposite, which would be negative 2. So our vertex is going to be the point 4, negative 2. Now, the next thing that I need to determine is how the parabola opens. So I notice that the y value is squared. So I'm going to go back to my formula and look. If the y is squared, then the parabola either opens to the left or to the right. Now, how do I determine which way it opens, whether it opens to the left or to the right? So the way that we're going to do that is we're going to look at this value right here. And if that value is negative, then we know that the parabola is going to open towards the left. It's going to face a negative direction. And if that value is positive, then the parabola is going to open to the right, facing a positive direction. So this parabola will open to the right. So knowing just those two things can allow me to go ahead and just do a basic sketch of what that parabola is going to look like. So I'm going to plot my vertex point at 4, negative 2. And I'm just going to very roughly sketch that parabola opening to the right. And we'll have to come back in a few minutes and make that sketch a little more precise. Okay, so let's go ahead and find our focus and our directrix. Now, remember in our formula that we have this value sitting in front of the parenthesis in both cases that says 4p. And so when I look at my problem, this 8 that we have here is the 4 times the p. And so I need to determine what the p was so that when I multiplied it by 4, I got 8. So 4 times what is going to simplify to 8? So I know that the p value is going to be 2. So what that tells me is that my distance from my vertex to my focus is going to be 2 units. So I'm going to come up here and I'm going to move over 2 units. And I'm going to place a point. This is going to be my focus. And that point is going to be at coordinates 6, -2. Now, I also know that the p-value helps me determine the location of the directrix. So if I count back 2 units, then right here I have that line that's going to be my directrix. So we have a distance of p from vertex to focus and also a distance of p from vertex to directrix. Now, what is the equation of that line? Well, it is a vertical line, and we know that vertical lines start out x is equal to. And what is x equal to? X is equal to 1, 2. X is equal to 2 is going to be my directrix. Now, we've done this part of the problem. The other thing that they're asking me to do is to graph. So we know our focus and our directrix. We know our vertex. What I don't necessarily know at this point is how wide or how narrow to graph the parabola. In other words, I mean, maybe our parabola looks like the one that I just drew, or maybe our parabola looks much more narrow like this, or maybe it's much wider. And so we have to determine the width on that parabola. So what we're going to do is we're going to choose 2 points that lie on the parabola, and that'll help us to draw a little more precise sketch. And we're going to use some very specific points. We're going to try to nail down a point that is directly above and below the focus. And we're using that because we already know something about the focus. We know that the focus has an x value of 6. And so what I'm going to do is I'm going to take that x value of 6 and I'm going to plug it into my equation. So I'm going to come over here and I'm going to say y plus 2 squared is equal to 8 times 6 minus 4. Okay, 6 minus 4 is 2, and 8 times 2 is 16. So we really have y plus 2 squared equals 16. And remember, we're going to try to solve it for y now. So I am going to take the square root of both sides. So that's going to give me y plus 2 is equal to positive or negative 4. Recall that when you take the square root of a number, you have to consider the positive or the negative. And then I'm going to subtract my 2 off. So if the 4 is positive, we're going to be looking at 4 minus 2, which will be 2. If the 4 is negative, we're going to be looking at negative 4 minus 2, which will be negative 6. So now I know 2 points. I know that the x value is 6, and I know that one possible y value is 2, and another possible y value is negative 6. And so we can plot those 2 points. So I'm going to go over 6 and up 2. And I'm going to go over 6 and down negative 6. And then I'm going to connect. So I'm going to come around and I'm going to draw that parabola coming through those 2 points. Now let me go ahead and show you the picture that they have so that we can see a little bit nicer, neater picture, okay? But basically exactly what we came up with when we sketched it out. Okay, so let's move on to a second example. So this time we want to graph the parabola negative y squared plus 2y, plus 2x plus 2y plus 5 is equal to 0. And we want to determine the focus and the directrix. Now, we saw this type of problem in the last section where the given equation was not in standard form. And so we need to first write the equation in standard form. So remember, we do that by looking at completing the square. So I'm going to rearrange my terms just a little bit. I'm going to put my y terms together. So that will be the negative y squared and the 2y. And I'm going to move the other terms to the other side. So that would mean subtracting a 5. And that would mean subtracting a 2x. Now I have this, except that I have a lot of negatives here. I think I'm going to go ahead before I do anything else, and I'm going to multiply every term in the equation by -1 just so that I don't have all the negatives. And that's just basically going to change my signs all the way through. Now I'm going to complete the square on the y's. So remember, completing the square means you're going to take your middle term, which for us is going to be a -2. You're going to multiply that by a half and then square. So half of -2 is -1. -1 squared is 1. And so I can add in a 1. I'm going to squeeze it in right here and also on the other side. So I have y squared minus 2y plus 1 is equal to 2x plus 6, combining those two number-like terms. All right, let's see if we can factor this. It would have to be y times y to make y squared. It would have to be 1 times 1 to make 1. Because we're aiming for a middle term of -2y, we would need both of these to be minus. And over here, I'm going to go ahead and pull my 2 to the front. So taking a 2 out of the 2x just leaves me an x. Taking a 2 out of 6 leaves me a 3. So I have y minus 1 squared is equal to 2 times x plus 3. And this is the standard form of the equation for our parabola. Now we need to come up with the information that we are being asked to find. And we can do that now that we are in standard form. Okay, so what is our vertex on this parabola? So remember that we're going to look in the x parenthesis, and we see the plus 3. So we're going to have a -3. We're going to look in the y parenthesis. We have a -1. We're going to have a +1. That's going to be my vertex. How's it going to open? Since the y is squared, we know that it'll either open to the left or to the right. And to determine left or right, we look at this number and determine whether it's positive or negative. Since it's positive, we know that the parabola will open to the right. Now, as we look at this number, this 2, remember that this is 4 times the p. And so it's been simplified to be 2. And so we have to determine what was the p-value so that when I multiplied it by 4, I got 2. And so if you can't figure that out, we could always come off to the side and ask ourselves, how is that possible for 4p to equal 2? Can divide both sides by 4, and so p would have to equal 1/2. And remember that that 1/2 is going to help us to determine the focus and also the directrix. Okay, so let's go ahead and real quick just sketch out a rough sketch of what we've got. I'm going to go ahead and plot my vertex at -3, +1. I know that the parabola opens to the right, so it's going to look something like that. And I know that my focus is going to move 1/2 of a unit on the inside of that parabola. So my focus is going to sit really close to that vertex. And so what is that point? So that point for my focus, it's not going to be a -3 because that would take me to the vertex. It's actually going to be a -2.5. So we would say maybe -5/2. And the height, the y value, stays at 1. Okay, now what about our directrix? So our directrix, we also use the p to determine the directrix. And so the directrix comes in 1/2 a unit on the back side. So very close, again, to that vertex point. And so, again, that is going to be a vertical line. So it's going to start out x is equal to, as all vertical lines do. And what is x equal to? Well, we know that we were at -3 when we were at the vertex, and then we went an additional 1/2. So -3.5 or -7/2. All right, so now we have found the focus and the directrix as they ask. And the last thing that we need to do is firm up our graph. Remember that the way to do that is to use the points above and below the focus. And so what we're going to do is we're going to look at our focus point and we're going to use the x value in the focus. So our x value is -5/2. We're going to plug that into our equation. So I will have y - 1 squared equals 2. And we're going to plug in the 5/2, that's negative, plus 3. All right, and then let's work it out. So you can use your calculator. -5/2 plus 3 is going to give you a positive 1/2. Two times 1/2 is going to give you 1. We then will take the square root of both sides. So we'll have y - 1 is equal to positive or -1. And we're going to add 1 to both sides. Now again, we have to consider both options. So if y is positive 1 and we add 1, we're going to get 2. If y is -1 and we add 1, we're going to get 0. So for our 2 points that we're going to be plotting, we're going to plot an x value of -5/2 and a y value of 2. And we're going to plot an x value of -5/2 and a y value of 0. And that will enable us to determine the actual shape of that parabola. And so I'll go ahead and show you what that's going to look like when we get that done. We can see that they have plotted those 2 points, the -5/2 and the 2, the -5/2 and the 0. We've got those 2 points plotted, which allows us to go ahead and draw a picture of that parabola.